Hello, and this is a video about how do we design solutions using model-based, utility-based agent architecture. By this time, we believe that students know the concept of rational agent, P's analysis, and properties of task environment, and they would be able to understand the various characteristics of model-based, utility-based agent architecture, and they would be able to design the solutions using them. Here we have taken an example of automated sprinkler. Now the question is why utility-based agent architecture is the most appropriate for this one. So the model-based agent architecture wherein it's supposed to react to only reflexes wouldn't be sufficient as the sprinklers are connected with plants, the green life, and if they are simply supposed to react to the reflexes, then they might not be able to maintain the plant conditions, the understand the soil levels, weather conditions, etc. So it's not very simple problem to be solved with reflex based architectures. Also, only achieving the goal of turning the sprinkler on or off at exact time is not the goal it is supposed to achieve. Instead, it is supposed to utilize in a proper way the water. Then it has to understand the moisture levels, the changing weather conditions, and so on. So keeping the sprinkler on or off at a precise time might make the environment happy in various parameters such as the water usage, the plant conditions, etc. And hence, it will not be just goal-based agent architecture, but this is going to be an agent architecture wherein it is going to achieve the goals. It's going to react to some of the reflexes, but everything would be done in a way that the environment would be happy or sad depending on the actions taken by the agent architecture, and hence this automated sprinkler agent would be utility based agent architecture. Let us start with P's analysis. So the performance measure can be rewarded or penalized depending on the plant health, then soil moisture maintenance, then water usage, responding to weather conditions. While as the actual environment would contain different gardens or fields which may contain different types of plants, they may have soils of different types and the soils might have different moisture levels. The areas may have different temperature fluctuation conditions in the day or in the seasons. The weather conditions might be changing as well. The agent is supposed to control the water walls, the sprinkler heads, water pressure regulators, etc. And to do all this, they are going to get the information from various sensors such as soil moisture sensor, the temperature sensor, humidity sensor, water flow sensor, and so on. Now we understand that performance measure has to be measurable, and in this case it has to make the environment happy or sad, and the happiness score would be assigned with some numerical values so that they can be compared against each other. So here for example, when the soil is slightly dry, then the sprinklers, if they are kept on for a shorter duration, then it's going to maintain the moisture level. At the same time, it's not going to waste the water, and hence the environment might be more happy and it might incur some rewards for the agent actions. While as during the rains, if the sprinklers are kept on, then it's going to waste the water and might make the environment unhappy, and so on. Properties of task environment, this is going to be partially observable because though it has got some sensors, the sensors are not going to give it the complete information about the underground water retention or unexpected plant conditions, unexpected weather conditions, etc. And hence it's going to be partially observable than being fully observable one. The system cannot also fully predict the environmental changes, and hence, given the state chosen the action, we cannot really predict the future states, and hence it's going to be stochastic and not a deterministic. The agent's actions taken today are going to affect the future states. For example, watering now and having the proper moisture maintained might not be required to water it again, but overwatering now might affect the soil conditions tomorrow, and so on. While the agent is operating, the environment might change and hence it is dynamic. The number of states, actions, and percepts are not going to be finite, and thus it is going to be continuous. And the sprinkler operating agent is the only agent working in the environment, making it single agent architecture. The reason is whenever we consider the ideal controlled environment, then the automated sprinkler system might be in the deterministic world. But when we consider an outdoor setting with more of natural weather conditions, the environment is a lot unpredictable, making it stochastic, and hence the property of task environment is more of stochastic and not a deterministic one. Moving ahead, and coming to the utility-based agent architecture, we are going to go through every block and the sample contents of every block moving forward. Starting with how the world evolves with and without agent, the agent must have information regarding various parameters, such as the soil moisture dynamics and the connection of it with the evaporation, then different plants and how much water do they absorb, then the water seepage, etc., the rainfall in that area or unpredictable rainfalls, etc. Then how the temperature changes with season, with time, and so on. The rainfall is random external factor. Then the rainfall amount is different during summer, winter, and monsoon, etc. The high speed winds might cause evaporation, also they might take some water blown away and so on. Also, the water tank levels are also important whenever we want to run the sprinkler system, and in case if there is no water, then the irrigation is impossible. What the world is like right now can be interpreted depending on the sensor information we have. For example, if the sensors are going to give us some information regarding soil moisture, then if it is below the optimal threshold or it's above that or it's at par, we must be able to understand that. The temperature from the reading, one should figure out if it is high, and accordingly how much effect is going to have on the evaporation, the humidity, rainfall detection, wind speed, etc. So there are various sensors. From the sensor information, the agent is supposed to interpret the current world information. Now, state and internal state. The internal state is going to maintain the percept history, while as the current percept would be given by the state. Combining both of them, one might interpret how the world is like right now. For example, the percept history might tell us that sprinklers were off in the last cycle, and the current sensors might tell us that the soil is dry, the temperature is very high, and we are not predicting any rainfall. That means the sprinklers have to be on probably. What my actions do? So these are the major actions considered, and what are the consequences of each one of them? That is, if the sprinklers are not kept on at all, then probably the soil might continue to dry and the plants may die. Then keeping the sprinklers on for a short duration might maintain the moisture levels and it might not result in overwatering, but running the sprinklers on for a longer time, it might um, overwater. Also, it might waste the water as well. So for each action, it has to know the consequences of them. Accordingly, with the consequences, how bad or worst the situation is going to be, or how good, better, best the situation is going to be, would be given to us by using the numerical utility values. For example, keeping the sprinklers off might be minus 30, while as keeping them on for a shorter duration might be plus 90, and running them for too long might incur the penalty or the sadness score to minus 70. Depending on the scenario and the information of how the world evolves, the agent should be able to choose one of the actions it should do now. So probably the chosen action could be turning the sprinklers on for a shorter duration. Why? Because it's going to maximize the happiness value and so on. This way, we can go through the various blocks given for utility-based agent architecture, and for the given problem statement, we can identify the sample contents that may go in each one of the blocks, and this way we will be able to design solutions for the same. Thank you.